In this video, what we're going to see is another equilibrium system that has got these beautiful colors. So we've got a royal blue kind of a color for the reactant, and then we've got a pale pink type of color in the products, and then we've got water and chlorides as well. Now, this equilibrium system, I want to point out the Kc for this would be CO H2O 2 positive plus C, or not plus, sorry, ooh, that's terrible, don't do that, times chlorides raised to the power of 4, and then we've got the cobalt chloride deal here, raised to the power of 1. But in this case, I do use water. And that is not common. The reason is that if we look at the state of matter for water, it is dissolved in alcohol along with all the other chemicals. And so water actually gets a molar volume because water is the solute now, it's not the solvent. So water would actually get included in this. And so to that end, we look at our first change and we're adding water. So by adding some water here, I'm actually adding water as an entity that is got molar concentration, so it needs to get used up, and so it's going to shift the equilibrium to use that water up. If these were AQ, that would not be the case, but because they're dissolved in alcohol, it does matter. Now, the using up the water shifts the equilibrium to the side that's more pale pink, and we can see that this is a more pale color because we've used up some of that royal blue color and produced more of the pink color. In the next test tube, what we've got is we've got the addition of hydrochloric acid. Now, significantly, this is concentrated hydrochloric acid. So we're adding a lot of hydrogen ions, we're adding a lot of chloride ions, and we're adding a little bit of water. So this is a really complex system, and it's only really easily explained if we look at the result. So here I can see that this is much more purple. I've got a much more purple color. It had to have shifted this way to produce the purple color. The reason is that we've added a lot of chloride ions, and so as we add those chloride ions, it shifts to the reactants, right? So it's shifting to the reactants to use up those extra chlorides. But subtly, there's another thing happening. We're adding a little bit of water because we've added aqueous hydrochloric acid. And so we're actually putting a little bit of water in. And so if this had been HCl and dissolved in alcohol, it actually would have shifted and made it more purple. But because it was HClAQ, it shifts back a little bit for the water. Now, I wouldn't expect you to come up with that on a test because that's a lot of explaining and understanding, and it's not very well predicted. But this, because we've got the evidence, we can explain it. And in the next example, the reason that this comes up, and I probably wouldn't even have picked up on it if it wasn't for this example, is in this case, we're adding HCl, so again, H plus, Cl negative, and H2O, but now it's a much lower concentration. So we're adding a lot more water this time than chlorides. So the chlorides are going to make it shift this way, but because there aren't very many of them, the effect of the water is actually stronger, and you can see that this becomes more of a pink color. By adding more water, it's shifting more to become that pale pink color, even though we're adding a few chloride ions. That's a really complex one. The last one is super important, and in this case, I really, really want you to watch the video and see this reaction that's happening in this last test tube. Because what is down here is a precipitate. So we've got silver ions, we've got chloride ions, and what happens is the silver ions are going to react, we have silver ions and we've added some nitrate ions. And what's going to happen is the silver ions react with these chloride ions to make silver chloride solid. And so what we're doing is we're actually removing the chlorides here. Those are removed. And as we remove them, the equilibrium shifts to use them up. And so by producing a solid precipitate, I'm able to remove an ion from it, and the equilibrium system shifts towards the products. And that's because the reverse reaction is going to be slowed down. There are fewer chlorides to do this that other reaction going this way. So we'll have one more video to explain the demonstration 3. That'll be